Um, Hi everyone. We will just start the class in 5 minutes. In the meanwhile, if someone have any doubt, you can put your doubts in the chat box, and I will just prepare the slides with them. Good evening, everyone. I'm Shefali Agarwal, and I am a PhD scholar at IIT Madras, and so I am your TA for the course of Advanced Concrete Technology. So this is our 5th TA session, and in this TA session we will be continuing our chemical admixture part, and we'll be starting about the mineral admixtures. So if we talk about, these are the course content, and we will be today completing our chemical admixture part and starting off with the mineral admixtures. So as we have studied in the last week, what we did in the last week, we talked about what are the chemical admixture, different type of chemical admixtures, and some basic properties of the chemical admixture. Here we will talk about mainly superplasticizer. So in this slides we are talking mainly about the superplasticizers. So to check the optimum dosage of superplasticizer, we are using a test called Marshcon test. In this test we have this conical flask kind of thing, and then we have a horizontal flask below this. So what we are doing, we are preparing a concrete mix of exactly this much quantity, and then we will cement paste, and then we will pour that cement paste into this conical flask. It will be closed from bottom. Then when we are opening it, we will starting noting down the point, and then until the time it is filled here, we will note down that point. That will give us the flow time. So if we see in this graph, it will give you the flow time. And how to calculate the optimum dosage? So at different percentage of superplasticizer, we will keep on calculating the flow time, and at the point when your transition from decreasing to constant become visible, that is called as optimum dosage. So it is the dosage where your your flow time become almost constant. Okay, this is the first test which we are, and main test to check the superplasticizer dosage, to calculate the superplasticizer dosage we are doing. And then how to calculate the optimum dosage in this case? So if you see first case, when you are there are two times, after initially and after 60 minutes, initially and after 60 minutes of making a cement paste. So when you are doing initially, if this is your graph, and after 60 minutes, if this is your graph, if both are coinciding at one point and giving the optimum dosage or anything, that is called as the compatible superplasticizer. But if in a case when you have a you have a completely different curve with at initial time and after 60 minutes, then it is incompatible superplasticizer. That means that superplasticizer is not compatible with the binder or concrete you are using at that particular day or time. Next test is same way as Marshcon test, we have mini slump test. So for for SP work, we check the slump test in concrete. So based on that only, we have made a small mini slump test. So we have this kind of small mini slump. It will be from inside, it will be in triangular shape like this. Sorry for the drawing. And you pour the concrete cement paste mix, and then just lift it up like normal slump test, and then you are calculating the spread value. So if it will be in circular way, you will calculate the spread value in this way, like 2-3 values you will take, and that will give you the spread in mm. So here again it will be percent SP, your x-axis. Okay, so with passage of time, your curve will shift downwards. That means your spread will decrease a little bit, or depending on how much after a flex time, or after how much time you are doing the test again. So these are the two tests which we are doing for superplasticizer. Next is the, once you have decided the optimum dosage or if your superplasticizer is compatible or not, what we will do, we will check the effect of temperature on different type of concrete. So mainly today we are using two type of superplasticizer, SNP and PCE based. So what is the difference between these two type of superplasticizer, if anybody will remember, like mechanism, based on their mechanism? So if you guys have you guys remember, in SNF based superplasticizer or chemical admixtures, the type of the mechanism followed mainly is electrostatic repulsion, right? And in the case of PC based superplasticizer, the mechanism followed is steric hindrance. So we have talked about it in details in last lecture. If you have remember or not, can go through it. So how at different temperatures, so this is like 6 degree Celsius, 15 degree, 27 degree, 35 and 45 degree Celsius with different percentage. So at this percentage, what is your slump value at 1 hour? Based on that, for different type of superplasticizer. So if you see in this case, with the changes temperature, your SNF things are changing variably. And however, in case of OPC also, your SNF your PCE based superplasticizer have varying variation, and same way for other two things. So if we talk about temperature versus superplasticizer dosage, so with increase in superplasticizer dosage, with increase in your temperature, your superplasticizer dosage required will also increase to give a particular amount of slump value. So in this case, we are keeping our temperature and the type of cement constant, type of cement and superplasticizer constant. In this case, what we are doing, we are keeping the temperature constant and the spread constant. We need 170 mm spread. So for 170 mm spread at a particular temperature, how much should be your SP dosage? So with increase in temperature, your SP dosage is also increasing. Okay. So that's what the test we are doing for superplasticizer. Along with, after superplasticizer, we have many other different type of chemical admixtures, and one of them chemical admixture is your set retardating admixture. Set setting admixture means the two type of which accelerate the setting time and which retard the setting time. That means if I am casting now, if I am concreting at this point, at exactly after 5 minutes, if I want to increase the setting time, if I want to decrease the setting time, if I want my concrete to set very fast, then I will use accelerator. However, in case like we have to ship our concrete from one place to another and there is too much distance in between, that time we will use some retarder so that your concrete mix doesn't set easily or quickly. Okay. So if you can see, if for a long haul application we are using retarders, and also in case of hot weather concreting, and they are workable for longer time. And accelerator, what are the advantages? Earlier finishing on slab, early edge strength, early removal of formwork, and mainly cold weather concreting. So if we divide accelerator and retarders, accelerator are mainly two types, chlorides and non-chlorides. Further, non-chlorides are organic and inorganic, and retarders are three types: organic, inorganic, and extended set. So this chloride based accelerators are mainly like calcium chlorides or sodium chlorides, and this non-chloride, in this we have in case of inorganic we have nitrates, nitrites. Organics we have amines. Those are the few example of accelerator. And in case of retarders, if we talk about organic retarders, so in organic retarders we have carbohydrates or some citric acid, or those things will come in organic retarders. And if you, I don't know if you guys have heard this story or sir have talked about it, that people used to add lemon to extend the setting time of concrete in some local places. So it is because of citric acid we can use it as an organic retarders, and inorganic retarders like borates, phosphates, those kind of thing. And then last is extended set retarders. These are like phosphorus. So where they are used mainly for plastic concrete, or when we have to use for long haul or carry the concrete for a longer time, that time we are using extended set retarders. So as we talked about set controllers, we have accelerator retarders. So other type of classification is we have 5 type of set retarders: 1, 2, 3, 4 and 5. So you can see all graphs are very much different. So how it is different? Set 1, if you talk about like this, with the increase in admixture concentration, your initial setting time also increases. So this type have example like gypsum. Okay, and then second time, yeah, admixture concentration is increasing, and then setting time is increasing and then decreasing. That is called that have some example as calcium chloride or calcium nitrite. Okay, and then we talk about third are almost similar to second one, but their initial setting time is very low as compared to second one. So in this case again we are using inorganic materials like potassium or sodium carbonates, sodium silicates. Type 4 is like a linear relation between admixture concentration and initial setting time. The example for this type of is lignosulfonates, the one we have already studied before, and some sodium salt of carboxylic acid. And type 5 is when you are increasing admixture concentration, your setting time decreases. Examples are like TA, formic acid, those kind of thing. Okay, next thing is these are the few set controllers, their examples, what are the few properties of them. Other type of special admixtures are sorry, air entraining agents. So especially in case where we have cold weather concreting, where water will get into the concrete during summer times, and during winter times that water will freeze, and we know ice surface area is more, so it will create pressure inside the concrete and there are chances of crack. So in that case what we are doing, we are adding some air entraining agents. So what air entraining agents will do, they will create a gap or create a bubble inside the concrete. So what happen, whenever water will enter those bubbles, it will expand in that bubble, it will melt in that bubble itself, so it won't create any extra pressure on our concrete surface. So those are the air entraining agents. So how they are working is like we have a polar group backbone, and then we have a chain of hydrophobic chain. So it is sort of like a detergent. So we have studied how a detergent works, surfactant work. The sorry, if we have any cement grain, what will happen, your polar group will get attached to your cement grain and your hydrophobic chain will be separated. Okay, in that case, and if there is any air void, what will happen, your side chain will get attracted to your air void, and your polar group will be on the other side. So in this way it will create some air gaps inside the cement grain or cement paste. So this air gap will be termed as will be there as an air bubbles inside your concrete, which will help your concrete to prevent freeze and thaw cracks. Okay, that is how air entraining admixtures work. Other different type of admixtures are like viscosity modifying admixture. If you want to provide stability to your extremely flowable concrete, we add viscosity modifying agents. And next is these are some example of your VMA only. biopolymers and their synthetics, and some what they are doing, they are actually thickening the concrete fluid. Other type of special admixtures are shrinkage reducing admixture. So mainly it won't be for a long term shrinkage, it is mainly plastic shrinkage and dry shrinkage, mainly plastic shrinkage. So to reduce plastic shrinkage we are adding some admixtures, and other type of admixtures are corrosion inhibitors. So corrosion inhibitors admixtures, when you are making RC type of structure, reinforced concrete structure, in that case you need corrosion inhibitors, so that instead of providing your repair to your concrete structure, you are already giving a admixture which won't react with your concrete surface, or can react with your concrete surface sometime, but will be attached on the steel surface which is present inside the concrete, and it will form a layer over the steel surface which will prevent the chloride ions to attack the steel surface. So mechanism of their action can be oxidizing or non-oxidizing passivator of steel, oxygen scavenger in the concrete system, film forming compound on the steel surface. Cathodic effect means they can make your cement paste more hydrophobic, which will lessen the pores and reduce the porosity of your concrete material. So there are some few examples, and at what dosage they are added, those kind of things. Other things are styrene butadiene latexes. So what they are doing is they form they improve the paste aggregate bond, or resistant to crack propagation, or provide water tightness to concrete. And some other type of compounds are there: antifreeze, waterproofing, alkali silica reaction mitigating admixtures. So you can read about them through the slides or research lecture also. So this is all about chemical admixtures. So if anybody have any doubt, you can ask now. Otherwise we can see what have been done in mineral admixture in this week. Okay, if there are no doubts, we will see about the mineral admixtures. So chemical admixtures are like this: small chemicals we are adding extra to the concrete material, and which are chemical based. Mineral admixtures are mainly when we want to replace our some material, like we want to replace a cement or sand or aggregates, we are using some waste byproducts which are called as mineral admixtures, also called as supplementary cementitious material. Okay, so sorry. So if we talk about what are the different type of mineral admixture based on their composition, so if we talk about mainly we have three oxides present in our concrete: calcium oxide, silicon oxide, and aluminum oxide, right? So if we see our normal concrete system, this lies in between silica and calcium hydroxide. So we have almost 60% of calcium hydroxide and 20% of silica hydroxide. Same way this is your PC. Based on their composition, we have different type of fly ash, GGBS, nature pozzolans. What are their position in our phase diagram? Same way, this is the similar thing, and it depends how you can calculate the composition of your different material. So if I want a composition of my slag, I will draw a line like this, and like this. I'm sorry, it should be actually from here it should go straight line, something like that, and then wherever it is meeting, that composition we can calculate, or whatever composition we want, we can, from that point you can put a perpendicular to all three axes and calculate the composition of exactly that point. Okay, so based on those things, what can be the compositional range of different type of SCM, and this is typical composition of a different type SCM. If we talk about Portland cement, we have almost 60%, 65% of calcium hydroxide, 21% of silica, and 5% of alumina. And in our slag system, what will happen? Your silica content will be higher, and that way your calcium hydroxide will reduce. Fly ash have maximum of silicon oxide, then aluminum oxide, and very less of calcium hydroxide. Class C fly ash have 35% of silicon oxide and 20% of calcium and aluminum oxide. And last is silica fume. So silica fume will won't have any calcium oxide present. It will only have 90% of silicon oxide present. So some main binders which have been used in the concrete. This is the microstructure of them: slag, metakaolin, fly ash, and microsilica. And next is, what are the different type of binders? How we are defining our SCM based on the binder system. First is hydraulic cement. Hydraulic cement means if we are adding any SCM to the concrete, it should behave like a cement. So what cement is happening? We are adding cement and water. So there is a quick reaction between cement and water. So if our SCM reacts with water without the need of any further activation, it is called as hydraulic cement type of binder. Okay. Next is latent hydraulic. It means if we add a small activators, any chemical or something, it will start behaving like a cement. So that is called as latent hydraulic binder. Last are pozzolanic. So pozzolanic means which are reacting with lime in the presence of water. So what is happening in this case? In this case, your SCMs are not behaving as a cement paste. In what they are doing, they are just they are decreasing the porosity of your concrete material. So how we can identify what are the composition of our SCM? We can use XRD study. In this case, if you see, these are the different XRD peaks of different type of materials. And if we are adding any type of reactive silica to calcium hydroxide, we are getting more of CSH thing. So we know whenever calcium hydroxide present in our OPC system, it is reacting with water. It is reacting with silica. It is form plus SiO2. Okay, the same equation is given. CSH is forming. So in this case, if you have more of reactive silica, more of CSH will form. So however the reaction is lime consuming, pore refining, so all these things are already given in the slides. You can go through it. So in this class, in this week, you might have started studying about fly ash. So fly ash are the byproducts of coal from thermal power plant, and the composition depends on the type of coal bit burnt. So we are dividing in two types: class F fly ash and class C fly ash. So how your fly ash bins collected directly? Mainly it is collected from the dump area where they have kept it in a slurry form, and it is typically done in electrostatic precipitator. So this is a diagram of electrostatic precipitator. So if this waste is waste will go here, and then we are using positively this collecting plates are there. All positively charged particles will get attached to it, and your waste gases will go here, and your negatively charged particle will be collected here and can be moved out. Okay. So that's all was there for this week as an theory. If you guys have any doubt, you can ask. Otherwise, we will see some question and answers for this week. You can put your question in chat box also. Okay, if there are no doubts, then we will see a few questions. So the first question is, beyond a certain dosage, the fluidity of the mix by adding superplasticizer does not change. Why this is happening? Because cement particles repel the superplasticizer molecule. Saturation with respect to superplasticizer adsorption on cement particles have reached. The superplasticizer will be reacting with the C3 particles. Superplasticizer evaporates before interacting with the cement particles. Anybody who B. Yeah, correct. So once you have reached a saturation point, what happen after that? Your superplasticizer won't react with any other material, any other particle, and you will get a similar optimum dosage in each cases. Question number 2. As per Atson, for the compatibility combination of cement and superplasticizer, the flow curves from the Marsh-Cohn test coincide at the time 0 and 60 minutes, 10 60 minutes, 0 100 minutes, or 0 10 minutes.
A.
Yeah, correct. So we have seen those two graphs. So we are checking at initially and after 60 minutes. So at whatever point they are clashing, we are calling it as an optimum dosage point. Third question is, the second generation admixtures can increase the slump of a no slump concrete to 250 mm. Is it a true or false statement? So there are three generations. Sorry.
False.
Okay. Yeah. So we have three generation of admixtures. If we now we are talking about the slump of a no slump concrete to 250 mm, that will come under generation second. Oh, sorry. Generation second can increase the slump of no slump to 50 mm. It is a false statement because it usually work at low slump of 25 to 50 mm. Okay. Next question is, choose the correct statement or statements. Reactive powder concrete is also known as high early strength concrete. Reactive powder concrete used only fine aggregates and not the coarse aggregates. Is it reactive powder concrete is intended to provide a compressive strength of more than 150 MPa. SNF admixture is typically used in reactive powder concrete.
A is correct.
A is correct. Okay. Any other statement do you think is correct?
B also correct.
B is also correct.
Sorry, which one? A, B.
Yes.
Yeah. So, sorry, B and C are the correct option. Why A is not correct? We will read it again. Reactive powder concrete is also known as high early strength concrete. So, if your concrete if you have a reactive powder, doesn't mean it will give you a high early strength to the concrete. It is just it means your C3S is reacting more, your CSH is forming more. Doesn't mean your you are getting a high early strength into the concrete powder. Second is reactive powder concrete used only fine aggregates and not the coarse aggregate. Yeah, this is true statement because when it is a sort of your micro concrete. So I think you all have heard about micro concreting. So it is just a powder which have the fine aggregates mixed with the cement particles, and you just add water to it. So it doesn't have coarse aggregate to it. And third is, it is intended to provide a compressive strength of more than 150 MPa. That is again, it is a long term thing. It doesn't means it gives you the high early strength, but we are assuming that our micro concrete or reactive powder concrete will have a very much higher compressive strength as compared to a normal concreting. So in that way, B and C are correct answer. Okay. So next question is, as the temperature increases, superplasticizer dosage to produce a given slump increases, decreasing, does not change.
Increase.
Increase. Correct.
Increase.
Increase.
So if from this graph you can see, if we want, if we have fixed our slump value, like in this case we have fixed our slump value to 170 mm. So if we are increasing our temperature, our dosage will also increase. Next question is, deformers are forming agent in air entrained concrete, admixture to prevent air entrainment, chemicals that prevent the bacterial growth in organic polymers, chemicals which facilitate effective dispersion of superplasticizer.
C.
Okay. Anybody else who thinks some other option is correct? So actually deformers are admixtures which will prevent air admixture, air entrainment. So from here itself, if you see the word foam, so it is creating a foaming effect. It is a sort of admixture which are used as air entraining admixtures. Okay. Next question is, accelerators increases the dissolution of calcium ion aluminates, silicates, both calcium and silicates, both calcium and aluminates. So in accelerator, what is happening? Your setting time is reducing. It is setting very fast, or the reaction is like rapid. So what is happening? If your reaction are happening quickly, your calcium and aluminate, or we can say C3S and sorry, C3A reaction should be quickly, right? If we see from our curve of like hydration peak curve, this is your C3S reaction, C3A and your C3S and C3A reaction and your initial hydration. So this initial peak is due to C3A dissolution, right? So if you want to make it as an accelerator, you should, this thing will shift this way, right? Your accelerator peak will shift towards left. So in this case you need reaction with calcium and aluminate, because your initial reaction is happening because of this initial reaction is happening because of C3A mainly. Okay. Next is, organic accelerators are chloride based. True or false?
True.
Okay, I will give you that graph. So mainly we have chloride and non-chloride based accelerators, and organic accelerator come under the
False.
false. Yeah, correct. Non-chloride accelerators. The air entrainers have a hydrophilic main chain with hydrophobic branches. True or false?
True.
It's false. Actually, it's completely opposite. Your your chain is hydrophilic and your polar group is hydrophobic. Your main chain is hydrophobic. Okay. The air entraining agents stabilize the air bubbles. Just give me 1 minute. Sorry. The air entraining agents stabilize the air bubbles generated by the agitation and mixing of concrete by altering the steric hindrance, charge on the surface of cement, surface tension of cement, surface tension of water.
Surface tension of water.
Okay, correct. So if you remember, we have this one cement particle, and in cement particle polar group will be in this way, and this is this way, and in air it will be like this. So how it is generating the bubbles? It is creating a surface tension, it is altering the surface tension of your water by attaching itself to cement grains and air particles in this way. Reducing the surface tension dash the capillary pressure increases, decreases, or does not change.
Decreases. B.
Increases.
No, it will decrease. If you are decreasing the surface tension, your capillary pressure will also decrease. So next question is, latex is a, so this is a special admixture. It is a suspension of sterylene in water, suspension of butadiene in water, solid solution of styrene and butadiene, suspension of sterylene and butadiene in water. So it is actually present in the slides, you can see through it. It is a suspension of sterylene and butadiene water. Next question is, dash base compounds are used in alkali silica reaction mitigating admixtures: magnesium, sodium, silicon, or lithium.
Lithium.
Correct.
Lithium.
So if we have to prevent alkali silica reaction, our admixture should have lithium compound to it. Among the following listed mechanism, which one is not relevant to corrosion inhibitor? Reducing the tensile stress on drying, film forming, oxidizing passivators, oxygen scavengers. A. Correct. So
A.
our corrosion inhibitors actually does not react with the, should not change the property of your concrete, and like it doesn't mean it is a golden rule that it won't change the property of the concrete, but it is not designed in that way that it will change the property of the concrete. However, it will behave as a film forming and passivator for steel and oxygen scavenger for the steel concrete interface. Next question is, VMA or viscosity modifying agents admixtures enhances the stability of mixes prone to segregation. True or false?
True.
True. Correct. So it will actually viscosity modifying will what will they will do? They will reduce the fluidity of your concrete. So what will happen? Your segregation will also decrease. So this is the application based question. A ready-mix concrete plant reports severe loss of slump during transportation, even though the same super plasticizer worked fine in the lab trials. What do you think is the most probable reason for this thing? Higher mixing speed at plant improves slump retention, delay between SP addition and placement, lower alkali content of cement, PCE admixture was mistakenly added instead of SNF. So in last lecture, if you remember, we talked about the properties of SNF based admixture and PCE based admixture. So your SNF based admixtures are very sensitive to time of addition and also are not suitable for long transportation. So therefore, if we are adding SP on the plant and then placing it at some other place at very long distance, then it will set very quickly. Okay. Contractor is preparing underwater concrete for pile foundations. Which admixture is essential to prevent washout of cement paste? SNF, air and draining agent, viscosity modifying agent, or shrinkage reducing admixture?
Viscosity modifying.
C.
Okay, correct. because VMA enhances cohesion, which make the concrete more resistant to washout under water. Next question is, shrinkage reducing admixtures work by increasing cement hydration, lowering surface tension of pore water, and draining micro air bubbles, or accelerating silicate dissolution.
B.
B, correct. So mostly it will prevent your plastic shrinkage. So what it is doing, it will reduce the surface tension of your pore water, which will prevent the formation of cracks or prevent the separation of your cement paste. Fly ash, silica fume, rice hash, they are all classified as hydraulic admixture, pozzolanic, non-pozzolanic, or inert filler.
B.
B, correct. So everyone know about fly ash. It is mostly a pozzolanic admixture. Same way for silica fume and rice hash. So the last question is, pozzolanic admixtures primarily react with which hydration product according to the phase diagram? CSH, ettringite, calcium hydroxide, C4AF.
C.
CSH.
No, CSH is the byproduct and reaction is with the calcium hydroxide. So your calcium hydroxide, CH, we have seen this equation before, plus silica, SiO2, and water, they will form CSH. Sorry for my writing. So the your hydration product is calcium hydroxide actually. So that's all for this week. If you guys have any doubt, please let me know, or you can contact me on my mail ID also. Okay, you can take 5 minutes. If you have any doubt, you can ask, otherwise we will close the class for today. Yeah, I will upload the lectures of the session by today or tomorrow. I think you guys might have access to the problem solving session Excel sheet. So there I will send the link. Actually, I forgot to upload the links. I will upload the link today. PPTs I will upload for PPTs. I think I have uploaded all. Session I will upload today. Recorded session. Okay, since there are no more doubts, then we will close the class for today. Thank you all for joining for this session.